Hello again. This is 10.6, which is binomial probability. We won't be doing the entire section in 10.6. We're actually just sticking to some basics of binomial probability. So binomial, you already know what binomial is, right? That would be a polynomial that has two terms. And so you'll see in a bit why this is called binomial probability. A binomial event for probability is an event where only two outcomes are possible. So examples of this would be, do I hit the target or do I not hit the target? Do I pass the test? Do I fail the test? Do I make or miss the basketball shot? Is the house blue or is it not blue? All of those, there's only two outcomes, right? And so those are all binomial events. And so turns out that for those binomial events, there's a formula for us to find the probability in any number. And so we're going to look at this example, and then I'll give you the formula for that afterwards. So I shoot 6 free throws. I have a 32% chance on each free throw that I might make it because I'm not very good at basketball. That's probably about right. I'm probably a little less than a third. So the probability that I would make all 6 of those, well, I would have a 32% chance, which is 0.32 of making the first one. And then I would have 0.32 of making the second one, 0.32 chance of making the third one, and then etc. And so that would be 0.32 multiplied by itself 6 times. So 0.32 to the 6th power would be 0.00107, etc. And so if I move the decimal to turn it into a percent, this would be fine to leave it not as a percent, or if you want to make it a percent, it would be a 0.11% chance, which is obviously really, really tiny. And so that one, we did not need binomial probability. They were just each of those was an independent event. And so I just took those 6 events and multiplied them together. I can do the same for the probability that I would not make any shots at all. If there's a 32% chance of making each free throw, then I can subtract that and I can get that would mean that there's a 68% chance that I would miss. So for me to miss every shot would be a 68% chance, and then times another 0.68, and then times another 0.68, and that would have to be multiplied by itself 6 times as well. 0.68 to the 6th power is 0.09887. It goes on past that, but so that would mean that would be my probability, or if you want to change that into a percent, that would be a 9.8, we'll go ahead and say 9.89% probability that I would not make any of those shots, which sounds about right. However, what's the probability that I would make 2 out of the 6 shots? So for this probability, I would say, okay, well, that means I need to make 2 of them. So I have a 0.32 chance of making the first, that one, right, 1, and then I have another 0.32 chance that I would have to multiply that I need to make for the second one. If I make 2 of the shots, it means I'm going to miss 4 of the shots, and I have a 68% chance of missing each shot, and I would need to miss 4 of those shots. And so this would be the probability, except for there's different ways that I could make exactly 2 of the shots. I could make the first 2, or the last 2, or the middle 2, or the first one and the 5th one. And so how many different orders are there? Because I need to multiply my probability by the numbers of different orders. Turns out that the number of orders there would be is, out of 6, I need to choose any 2 of those. And so that's going to be the raw coefficient that's in front of it as well. And then I would have 0.32 squared and 0.68 to the 4th power. So 6 choose 2, you can find from Pascal's triangle, is 15. Or you can type it in your calculator. And then we would do 15, we would multiply 15 by 0.32 squared by 0.68 to the 4th power. And we'll see what that is. And that would be 32.84%. So again, watch out, especially on big ideas, watch out for whether it asks you for the percent chance or just the probability. If it only asks you for the probability and not a percent, we would leave that as 0.328, right? And not move the decimal and not change that into a percent. And so you can see that what I've done here in the middle, that's your binomial probability formula for how to make or how to, what's the probability of 2 successes happening out of 6 tries. And then you've got your probability of success and you've got your probability of failure. So I'm going to go ahead and give you a formula for that, I guess. So actually, I'm not going to give you a formula for it. I take it back. I'm just going to do this last example for you, and then I think you'll be fine, because we're not doing the whole section. We're only just doing this little bit. So there are 80 algebra students that I have in my Algebra 2 classes, I think, around there. 55 of you are in the 10th grade. Again, approximately 55 of you are in the 10th grade. So if I pick 5 students to automatically receive an A on their next celebration, then what's the probability that at least 3 are 10th graders? So that means I could have all 5 10th graders, or 4 or 3 10th graders. And I'm going to need to find those probabilities and then add them up. So the probability that exactly 3 would be in the 10th grade would be, out of 5 students that I'm picking, I would need to choose 3 of them. That's how many orders that there can be. And then the probability of being a 10th grader is 55/80ths, which we can reduce if you want. And I would need to have 3 10th graders. And that means I would need to have 2 students that were from other grades. And so if you subtract 55/80ths from 1, you would get that would be 25/80ths would be the probability of not being a 10th grader. So the 5 choose 3 is the number of ways that it can happen. And then this is the probability that I need times, times itself, the number of times that I need that. And then the probability of not being a 10th grader and how many not 10th graders I need. So let's go ahead and calculate that. So I'm going to go ahead and find 5 choose 3. I'm going to show you that on my calculator again, in case you had not been able to watch the last lesson. So we're going to clear the history and clear the calculator. Okay, so we're going to go to 5 and then find the math button and move to the probability tab. And then we want NCR because we're choosing, and we have 5 and we're choosing 3. And that tells me that 5 choose 3 is 10, which means there'd be 10 different orders that could happen that we don't care about the order. So this would be 10 here. And then we'll go ahead and calculate that. So 10 times 55/80ths cubed times 25/80ths, and you can simplify them in your calculator if you want, squared, ends up being 0.3173, etc. So that would be the probability that exactly 3 of them, right? And I'll go ahead and rewrite this so my work is consistent. That would be the probability that any 3 would be 10th graders. So then I need to also do, because the question said at least 3, so that means it could be 3 or 4 or 5. So I'm going to go ahead and say, well, that was fun, but now I'll find 4, and then I'll find 5, and then I'll add all those up. So the probability that 4 of you would be in the 10th grade that I would pick would be 5 choose 4, and then 55/80ths, which is my chance of being a 10th grader or picking a 10th grader. And I would need to pick 4 10th graders, and 25/80ths, which would be not 10th grade. And I would need to pick 1 not 10th grader. And so I would go ahead and calculate this. So it turns out 5 choose 4 is 5. And so I would do 5 times 55/80ths to the 4th power, and then multiply that by 25/80ths to the 1st power, and I get 30.3491. As I do this, I hope that you're pausing the video and typing them in yourself as well, just to follow along with me and check and make sure that you can get the same numbers. So, etc. So that would be the probability of getting, picking 4 10th graders. And then I need also then the probability of picking all 5 10th graders. Well, I can set it up on my formula if I wanted to, but that would be 5 choose 5. And then I'd need 55/80ths. I'd need 5 of those. And then I'd need 25/80ths. I would need 0 of those. And so you can see that this is 5 choose 5, which is 1. And then I've got the 55/80ths to the 5th power. And then 25/80ths to the 0 power is also 1. Really, we didn't need to set up that formula. If all 5 of them needed to be in the 10th grade, then that would just be 55/80ths to the 5th power, which would be 0.1536, approximately, right? So notice then, if I want at least 3 to be in the 10th grade, then that means 3, 4, or 5. So I would simply add all those up, and I would say, all right, so then what is, move this out of the way, what is 0.3173 plus 0.3491 plus 0.1536? There we go, and we'll add all those up. 0.3173 plus 0.3491 plus 0.1536, and we'll get that that's 0.82, approximately, because I had rounded those. So that's approximately 0.82 probability that at least 3 of them are 10th grade. And then if we wanted to, we could also calculate the probability that 2 of you would be in the 10th grade, 1 of you would be in the 10th grade, or 0 of you would be in the 10th grade. So there would be 6 options, right? From all the way from 0 to 5. So 0, 1, 2, 3, 4, or 5. And those 6 options all added up should equal 1, because one of those 6 outcomes has to happen. So there you go. There is some binomial probability for you. And now you can get to your 10.6 homework. That was also the last section that we're going to be doing in chapter 10. So it looks like you're good to go. Have a good day.